So in this video, we will be looking on the term signal Ogle diagram and all. So here, why term symbol? So before learning the term symbol, we should be known with the RS coupling or LS coupling. RS coupling or LS coupling. The thing is that this coupling scheme provide or this helped in determining the term symbol. So in term symbol we have certain symbol. It is generally N, L, J. So what is N, what is L, what is J? You should be knowing. So first one is L term. So the L term, it is if L equal to 0, the symbol is yes for 1P, for 2D, 3F, 4G and so on. Then the S term. S term is the spin angular momentum source. So L is the capital L is the resultant orbital angular momentum quantum number. Small l represents the orbital angular momentum quantum number. The resultant overall angular momentum orbital momentum quantum number is what? Capital L, and small l, it's different. Small l is actually used in finding the different terms. Okay, so S term, it is the spin angular momentum, which is generally n by 2, where n is the number of unpaired electrons. So if we consider a p2 orbital, we know there are 2 unpaired electrons, right? So the S will be 2 by 2, means 1. Then the J term means it corresponds to the total angular momentum quantum number. J term or LS coupling term. Okay, it is the summation of L and S, which means L minus S. J is L minus S to L plus S. If it is less than half filled, we consider only L minus S. If it is more than half filled, we will consider L plus S. So generally it is from L minus S to L plus S. Then comes the M term or spin multiplicity, which is N plus 1. Generally M in we usually use N there, and N is 2S plus 1. We consider that equation instead. So for D4 configuration, it's given that for D4 configuration, this is how the atomic orbitals are occupied generally according to Hund's rule. So here we can see that in this 5 orbitals, we have 4 half-filled orbitals, right? So 4 orbitals are singly occupied. So what will be the spin? Spin will be, each arrow can be considered as a spin of 1 by 2. So the total spin will be 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. So it is 2, right? Our S is found to be 2. We know N is 2S plus 1. So N will be N will be 2S plus S, means 4, and our total spin will be 4 by 2, which is 2. Now J means L minus before that we should know what is L. L can be found as 2 into 1 plus 1 into 1 plus 0 into 1 plus minus 1 into 1. So resultant will be 2. Correspondingly, for as we have look, if we get a L equal to 2, then our resultant will be, term will be D, right? So that is what L equal to 2 means, D, representation D. Then S equal to N, which is N by 2, which is 4 by 2. 4, how you get 4 by 2? Because we found it using 2n plus 1 and so and so. Then J is L minus S, which is 0 here. Since both are 2 minus 2, 0. M will be 4 plus 1, which is 5. That is what I had said, that 2n plus 1. 2 into 2 plus 1, which is 5. Then, so our resultant term symbol will be 5D0. Okay. So that is for D4 configuration. Do yourself practice for every configurations from D1 to D9. Now you should find the number of microstates also. So Hund's rule for ground term, it is relatively easy to calculate the term symbol for ground state of an atom using Hund's rule. It corresponds to state with maximum S and L. So number of microstates, which is n factorial by r factorial into n minus r factorial. So here n factorial, it is equal to 2 into 2 plus 1 or 2 into 2x plus 1, something like that. That we will be looking further. where n is the maximum capacity of the configuration, r is the number of electrons in configuration. So here we have certain rules to be followed. First one is according to Hund's rule only. According to Hund's rule, the various electronic arrangements, that arrangements which having the maximum value of spin multiplicity will have the possibility to ground state. Like Hund's rule, you know what's Hund's rule. Then if more than one electronic arrangement have same value of spin multiplicity, then the electronic arrangement with higher L value will be the ground state electron arrangement. Then the third rule is in the ground state electronic arrangement, if the configuration being less than half filled, the least G value being actual J value, while if it is more than the maximum J value, that is what more than less than half filled, we consider L minus S. Now coming to the Ogle diagram. So this is the example for detail